Hello, geographers, and welcome to another episode of Learning. This is Climate Change Heating the Earth? The title of this chapter in the textbook is really kind of a little bit outdated. There was quite a big disinformation campaign by fossil fuel interests to try and suggest that climate change wasn't happening, and like even 5 years ago it was like, oh, is it happening, is it not happening? The short answer to the question, is climate change heating the earth? Yes, definitely. The long answer is yes, definitely, because it 100% is. But we're going to look at some material about how climate change is heating the earth. Some learning goals for today, fine people. You're going to know these terms: climate, climate change, greenhouse effect, and global warming. Now, there's quite a bit of confusion about these words, and the negative environmental thing that we now call climate change used to have different names. So just briefly, it used to be called the greenhouse effect. Then it used to be called global warming, but now we call it climate change. Just to summarize, the greenhouse effect is just what happens when the atmosphere traps certain gases on Earth and keeps us warm. If we didn't have any greenhouse effect at all, we would all be dead because it would be freezing cold. Just like in a greenhouse, yeah? The glass keeps heat in, makes your plants grow quicker. What the problem is we now have what's called the enhanced greenhouse effect, where we're trapping too many of those gases in. Climate change is the name given to the global effects of these gases being trapped. It used to be called global warming. However, we don't call it global warming anymore because global warming is just one of the effects of climate change. Okay, climate change has global warming, sea level rise, lots of dead animals, everybody needing to turn their air conditioner on, blah 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 blah. So the greenhouse effect by itself isn't bad. The enhanced greenhouse effect is. Climate change is what causes global warming and other negative things as well. And an early slide is going to talk about the difference between climate and weather. And you'd be surprised at how many people don't know the difference between that, including some politicians of very large countries. Anyway, you're also going to know the effects of climate change on Australia. And you're going to know how we can reduce our carbon footprint. Okay, climate change and global warming. So, climate is not the same as weather. Weather is the state of the atmosphere in one place at one time. I might say, hey Google, what's the weather today?
Today in Keilor East, it'll be sunny with a forecasted high of 13 and a low of 4. It's currently 11 degrees and partly cloudy.
Right, so the weather where I am is 11 and partly cloudy. The climate where I am is not 11 and partly cloudy. The climate of southern Victoria is temperate, coastal, with an average temperature range of between 10 and 20 in winter and between 25 and 35 in summer. Okay? Climate is the average state of the atmosphere in a large area over time. The simple way to think about it is weather is what's happening where you are today. Climate is what happens in the entire state or a large area over a long period of time, like what the average weather conditions are over years. Yeah, weather is climate is Great analogy. Here is a funky little image that explains in graphic terms exactly what I just said. The weather is conditions of the atmosphere over a short period of time. It can change within minutes or hours. The climate is the atmosphere over a long period of time and space. Yep. So the climate changes slowly, the weather can change in a couple of minutes. You know what it's like if you live in Melbourne. 4 Seasons in One Day was sung about Melbourne because its weather changes so quickly, but climate changes very slowly, if at all. We have climate change at the moment, but it's only rising the average temperature on the whole Earth by you know, it's changed, it's increased by 1 degree in the last 250 years, and that's considered a bad thing. It is a bad thing. Right, now the greenhouse effect. Remember, the greenhouse effect is the sun's energy gets trapped inside the Earth's atmosphere. Okay, that's the layer of gases. It keeps us warm. If we didn't have any greenhouse effect, we would die from the cold. The greenhouse effect is not the problem. It's what we are calling the enhanced greenhouse effect. That's where too many gases, like carbon dioxide, trapped in the atmosphere, make it heat up more. So the average temperature on Earth, if you remember back a couple of lessons, is 15 degrees. Yeah, that's increased by 1 degree since the Industrial Revolution, when we started pumping out heaps of fossil fuels into the atmosphere. Oh, 1 degree, that's not much, I hear you say. Well, it is. If we don't do anything about climate change, the average temperature is going to be somewhere between 4 and 6 degrees hotter than it normally would be by 2100. And that's really bad because the Ice Age was only, the Earth's average temperature was only 6 degrees less than it is now, and when we had an Ice Age. And so at the moment it's 15 degrees. If we don't do anything about climate change, it might go up to like 19, 21 degrees on average across the world by 2100. The last Ice Age was 9 degrees, but in that last Ice Age we had the oceans were hundreds of meters lower. You could walk to Tasmania. There were ice sheets 1 kilometer thick as far south as New York. So it was a completely different world, and not a world that we could live in very easily. So even though the changes in temperature seem small, they make a huge difference. And when we say that the average temperature has increased, the average temperature doesn't increase uniformly across the world. The average temperature might go from 15 to 16, but in some parts it might not change very much at all. For example, New Zealand's not going to have very many negative effects of climate change, but places like the Arctic and the Antarctic are suffering much greater changes in temperature. And there's a lot of evidence to suggest that the Arctic, that the North Pole, is in fact going to completely melt within your lifetime. In fact, that's almost certain. So the result of the greenhouse effect is climate change, and one effect of climate change is global warming. So we go gases getting trapped in the atmosphere, which is the enhanced greenhouse effect, climate change, and from climate change we see global warming, rising sea levels, dead animals, and so on. Okay, here is what I hope is a simple diagram showing the greenhouse effect. We have the sun over here. Hello, sun, you big ball of chemical reactions, sending down energy. Boom. Enters the Earth's atmosphere. Some of it goes back out into space. Twang. But some of it gets trapped inside the atmosphere by greenhouse gases. That's a good thing. The Earth's average temperature is 15 degrees. If there was no greenhouse effect, it would be minus 17 degrees. And I can tell you right now, if the average temperature on Earth was minus 17 degrees all the time, we would not exist. So remember, greenhouse effect, good. Enhanced greenhouse effect, bad. Produces climate change, which produces global warming, sea level rise, dead animals, sweating. So what kind of effects are we going to see from climate change in Australia? There are heaps, and here's a few. Higher average temperatures. Australia's already a very hot place, so that's not going to be great. The sea level is going to rise, which means that places that are on the coast are going to suffer coastal erosion. Houses are going to sink into the ocean. We're already starting to see this. Even in Melbourne, coastal suburbs like Elwood and Elsternwick are suffering coastal erosion and flooding on an annual basis. Places like Venice now have like 150 days of the year when St. Mark's Square is underwater. So sea level rise already happening. We're also going to see heavier rainfall. Now, why is this a problem? In a city where most of the soil and dirt has been concreted over. Now, normally when it rains, most of that rain just sinks straight into the soil. Of course, when you concrete over that soil, and the rain has to wash off somewhere, and so you get all of the stormwater, and so you have what's called flash flooding. And it happens quite often in Melbourne CBD now. There'll be a really, really big downpour that only lasts a couple of hours, but because there's no soil for it to go into, it backs up massively. It goes down the stormwater drains, but the stormwater drains get blocked, and so you get the CBD under a little bit of water just for a tiny little amount of time. Yeah. So the reason why climate change produces heavier rainfall is because hot air can hold more moisture in it. Yeah. When the average air temperature is hotter, there's more moisture in the air, so that you can have more rain in the air. True fact. There are going to be more bushfires, and if we weren't in the middle of a global pandemic, you would have acknowledged that the bushfires that happened last summer were the worst thing that's happened to Australia recently. And all scientists acknowledge that climate change is having a really, really bad effect on bushfires, especially in Australia. There's going to be less snow, more rain, but less snow. And obviously you can't ski or snowboard on rain. So yeah, you know, if you've ever been up the mountain and there's heaps of snow there, but then it starts raining, the rain melts the snow. And why is there being less snow bad? Because that's going to destroy all of the tourist industry that relies on snow. And bigger storms. Hotter air, more moisture is in the air, and so when there are storms, they are worse, bigger, and have more catastrophic effects on buildings and whatever that's in their path. And we're seeing way bigger superstorms happening all around the world. If you have a look at a graph of the number of storms that have been happening and how bad they are, it's getting a lot worse. Okay, so here are 8 things that are negative effects of climate change on Australia. Average rainfall is going to change. Some parts are going to get drier, some parts are going to get wetter. Either way, it's going to be a really big change. Frequency of extreme sea level events, so the sea level is going to rise, but you also get storm surges, which means that the sea level at the coast is much worse during that storm, which means that all the housing and urban infrastructure that's near the coast gets damaged. Think Superstorm Sandy that happened in the US about 5 years ago. That was pretty bad. Ocean acidification. As the ocean absorbs carbon dioxide, it becomes more acidic. Now, why is that a problem? The world's biggest coral reef off the coast of Queensland, you might know it as the Great Barrier Reef, relies on shellfish being able to produce shells. If the water in that area is too acidic, they cannot produce shells, and that's one of the main reasons why the Great Barrier Reef is under threat. Also, simply the increase in the water temperature, we are seeing bleaching events. That naughty starfish is also causing problems. I'm not going to say it's all climate change, but anyway, the Great Barrier Reef is not having a good time at the moment. More tropical cyclones, more hot days, fewer cool days, extreme fire weather, and an increase in drought. I know it seems bizarre that in some areas are going to have extreme rainfall and other areas are going to have drought. That's just simply one of the effects of climate change, is that we are going to have more extreme weather at both ends of the scale in terms of rainfall. Is it all doom and gloom? Let's not think like that. What can we do about it? We can use renewable energy. One of the main sources of greenhouse pollution is burning fossil fuels. The main source of electricity generation in Australia currently is burning coal. How mad is that? So we can use solar panels and wind power, and at our school we do use solar panels. I've got some solar panels right there. Yay! We can use energy efficient lights and appliances, and believe it or not, we can eat less meat. Meat production is very greenhouse intensive because Cows produce a lot of methane, which is another another greenhouse gas from burping. I know everybody thinks it's from farting, but it's primarily from burping, because cows have 4 stomachs and they eat their food and then they bring it back up and then they chew it again, and that act produces a lot of methane coming out of their mouths, which is a really, really bad greenhouse gas. There are 3 main greenhouse gases: carbon dioxide, which is the main one you hear about, methane, and nitrous oxide. But the main one humans are responsible for directly is carbon dioxide. Methane is much worse, but there's a lot less of it, and a lot of that comes from animals, cows that we eat. So if we stopped eating beef, we would reduce our amount of methane that we produce big time. And nitrous oxide comes from a lot of industrial processes that we have. Here's a very short little infographic with suggestions about what you can do at the personal level to reduce your impact on greenhouse gas emissions. Turn lights off. Take the stairs rather than the lift. If the air conditioner's on, shut the windows, it'll use less electricity. Take shorter showers. Turn your laptop off. All of these things are about reducing electricity. Now, if all your electricity is produced from solar energy, use as much of it as you want. But currently, most of Australia's electricity is made from burning coal, so we should be using less of it. Here's a very interesting slide. This shows how much of an impact different things have on reducing carbon emissions. So everyone's like, oh yeah, change your light bulbs to those new energy efficient ones. Yeah, that's fine. It's a good idea. But it doesn't make that much of a difference. Whereas having one less child makes a huge difference. Now, obviously, most of you guys are too young for that, but anyway. So there you go. All right, it's activity time. Did you notice that I've got a giant hat that looks like a banana? Yes. Anyway, we're going to do some graphing. So you're going to need to get some grid paper out of your maths book and glue a whole page of it into humanities exercise book. If you can't do that, you could print out a grid or roll up a grid, but it needs to be like, 1 centimeter by 1 centimeter square. So it's a lot easier to do it just with some grid paper from your maths book. Anyway, you're going to make a bar or a line graph. So line graphs are really good for showing change over time. So are bar graphs. Bar graphs are also just good for showing comparisons. So you can pick which of those 2 you want, but remember to include bouts. That's border, orientation, border, label your axes, a legend, title, and the source of the information. You can say the source of the information is moi, if you like. And you're going to graph this data. This will be a graph where you're showing the increase in carbon dioxide, CO2, in the atmosphere. So ppm stands for parts per million. So it's the density of carbon dioxide in our atmosphere, and as you'll see there, it's going up. So you have to make a graph about it. Fun for you. Okay, our first video is from my favourite scientist. It's Neil deGrasse Tyson, and this is a really simple explanation of climate change. Take it away.
In 1960, Carl Sagan's PhD thesis included the first calculation of the runaway greenhouse effect on Venus. This was part of a career-long interest in the atmospheres of the planets, including our own. In the original Cosmos series in 1980, Carl Sagan warned,
"We are releasing vast quantities of carbon dioxide, increasing the greenhouse effect. It may not take much to destabilize the Earth's climate, to convert this heaven, our only home in the cosmos, into a kind of hell."
Incoming light from the sun hits the surface. The Earth absorbs much of that energy, which heats the planet up and makes the surface glow in infrared light. But the carbon dioxide in the atmosphere absorbs most of that outgoing heat radiation, sending much of it right back to the surface. This makes the planet even warmer. That's all there is to the greenhouse effect. It's basic physics, just bookkeeping of the energy flow. There's nothing controversial about it. If we didn't have any carbon dioxide in our atmosphere, the Earth would just be a great big snowball, and we wouldn't be here. So a little greenhouse effect is a good thing, but a big one can destabilize the climate and wreck our way of life. All right, but how do we know that we're the problem? Maybe the Earth itself is causing the rise in CO2. Maybe it has nothing to do with the coal and oil we burn. Maybe it's those damn volcanoes. Every few years, Mount Etna in Sicily blows its stack. Each big eruption sends millions of tons of CO2 into the atmosphere. Now, combine that with the output of all the other volcanic activity on the planet. Let's take the largest scientific estimate, about 500 million tons of volcanic CO2 entering the atmosphere every year. Sounds like a lot, right? But that's not even 2% of the 30 billion tons of CO2 that our civilization is cranking out every year. And funny thing, the measured increase in CO2 in the atmosphere tallies with the known amount we're dumping there by burning coal, oil, and gas. Volcanic CO2 has a distinct signature. It's slightly heavier than the kind produced by burning fossil fuels. We can tell the difference between the two when we examine them at the atomic level. It's clear that the increased CO2 in the air is not from volcanoes. What's more, the observed warming is as much as predicted from the measured increase in carbon dioxide. It's a pretty tight case. Our fingerprints are all over this one. How much is 30 billion tons of CO2 per year? If you compressed it into solid form, it would occupy about the same volume as the White Cliffs of Dover. And we're adding that much CO2 to the air every year, relentlessly, year after year. Unlucky for us, the main waste product of our civilization is not just any substance. It happens to be the chief climate regulating gas of our global thermostat, year in, year out. Too bad CO2 is an invisible gas. Maybe if we could see it. If our eyes were sensitive to CO2, and perhaps there are such beings in the cosmos, if we could see all that carbon dioxide, then we would overcome the denial and grasp the magnitude of our impact on the atmosphere.
Another one of my favourite scientists. He's a science communicator, and his name's Bill Nye, and this is him talking about climate change 101. Go, Bill.
We hear it so much that it feels like a buzzword, but it is far from it. Climate change is a real and serious issue. But isn't the climate always changing? What exactly is climate change, and why should we care? Well, the Earth's climate has changed throughout history. Most of these slight changes are caused by small variations in the Earth's orbit. But climate change as we know it today is characterized by an abrupt increase in the Earth's temperature. It is estimated to have gotten 1.2 to 1.4 degrees Fahrenheit warmer in just the last century. 10 out of the last 13 years were the warmest on record. 97% of climate scientists agree that this new tendency is not caused by the variations of the Earth's orbit, but rather very likely caused by human activities. That means you and me. And since the Industrial Revolution, we have come a long way. Humans built airplanes, faster cars, developed remarkable technology, and learned how the natural resources around us can be used for our benefit. Although this has led to many wonderful inventions and advancements, like the device you're using to watch this video, or the ability to take a plane halfway around the world, it also means we've increased our consumption of natural resources and in turn released a lot of greenhouse gases into the atmosphere. Now, greenhouse gases occur naturally, but in excess can be dangerous to our planet. Modern human activities have increased the release of non-naturally occurring greenhouse gases because we have stepped up our demand for burning fossil fuels. The composition of greenhouse gases traps heat radiated from the sun. The more heat they trap, the warmer our planet gets. And as our planet gets warmer, we begin to feel the effects. One of climate change's biggest victims is our oceans. Oceans regulate the Earth's temperature and provide 50% of the Earth's oxygen. Now, climate change has increased the global temperature of the oceans by more than 0.3 degrees Fahrenheit since 1969. Although a warmer ocean might seem inviting to a beachgoer, it actually has devastating consequences for supporting life at sea. One of those consequences is ocean acidification, a direct effect of increased dissolved CO2. Since the late 18th century, ocean surface acidification has increased by 30%. A higher acid content means calcifying species, like oysters and clams and shallow water corals, are at risk, putting the entire ocean food web at risk. This is bad news for the 1 billion people relying on the ocean as its primary source of protein. Climate change has also caused the sea level to rise. Just in the last century, sea levels have risen 6.7 inches, but the rate in the last decade has nearly doubled. Sea levels have risen because as the ocean gets warmer, it swells. On top of that, glaciers and ice sheets are melting. Antarctica lost 36 cubic miles of ice between 2002 and 2005, and since 1994, each year on average, the Earth has lost 400 billion tons from its glaciers. That's like an ice cube 7.5 kilometers on a side, 4 miles on a side, melting and flowing into the sea. When all that ice melts, it fills up our oceans, and just like filling up a bathtub, the shores can't hold all that water, and coastal regions get flooded. Troubling signs of climate change are increased extreme weather events. Natural disasters like floods, tornadoes, and deadly heat waves are more obvious to humans because of their immediate impact and their sharing of the images in the media. Climate change, as we know it today, is change in our Earth's overall temperature with massive and permanent ramifications. Although its consequences can be planet-threatening, scientists still believe there are things we can do on a personal level to help. Recycle and reuse things. Walk or use public transportation to get to work. Turn off your electronics when you're not using them. Eat less meat. While you're at it, eat more locally grown vegetables and foods. And last but not least, spread your knowledge and concerns about climate change with others. When it comes to climate change, the main takeaway is that it's real. And although we are part of the cause, we can also be part of the solution.
Okay, really simple reflection activity today. When you think about climate change, I want you to do a CSI, which is colour, symbol and image. So when you think about climate change, what colour comes to mind? When you think about climate change, what symbol comes to mind? Just draw a little symbol. When you think about climate change, what image, what picture? So I want you to draw a picture, yeah? So you just got to give a colour, a symbol, which is just a little, and then image, like an actual drawing. Drawing only needs to take you a couple of minutes. I'm sure there's a lot of amazing latent art experts out there. Can't wait to see it. Thank you so much for participating in today's lesson, and do not ever forget to keep it real.